Okay, so now let's look at a couple of questions. The first one is evaluate the improper integral or state that it is divergent. Okay, so talking about the improper integral, that means you have two improper type of integral. One is one of the limit it get involved with infinity. Or the other type of the improper integral is, from the lower limit to the upper limit, there is one value will make the integrand not defined. That's the type 2 improper integral. The type 1 improper integral is just involved with, either positive infinity or negative infinity. So for this situation here, this is number one. What we can do is from negative infinity to negative 4, 5x over x cubed dx. What we can do is we can transform this problem into a limit problem, and that's all it is. That is also the way we handle this improper integral. Set up that integral from b to negative 4, and then after you evaluate this definite integral, then you take the limit, let b approaches negative infinity. So that's the way how we handle that. And so you got the limit as b goes to negative infinity. To integrate this is going to be 5 times x to the power of negative 3 plus 1 over negative 3 plus 1, right? Evaluate from b to negative 4. So yeah, that is exactly what we want. So limit b goes to negative infinity, so it's a 5. You can do, actually it's over 2, right? X to the power negative 2 can be into x squared, evaluated from b to negative 4. So we can plug in negative 4 there, so it gives us is oh, excuse me, I missed a negative here, right? So if we put a negative 4 there, so what do we get? We're gonna have it's 5 over negative 2 times negative 4 squared, right? And then minus 5 over negative 2 times b squared, right? And then also, don't forget we have this limit as b goes to negative infinity. Okay. So if you simplify this part, that's going to be limit b goes to negative infinity, 5 over negative 32, okay? And then it's minus becomes into plus, so it's a plus 5 over 2b squared. And turns out that as b approaches to negative infinity, do you realize that this part actually goes to 0, right? So hence this is going to give us is 5 over negative 32. And if you check that, the answer for this one is going to be D. Okay, so that's number one. Number two, so it's x to the power 7, e to the power of negative 8, and e to the power of negative x to the power 8 from negative infinity to positive infinity dx. Again, what we can do here is we can do this way, right? We can do this way. X7 dx. Okay. So that's the problem. Turns out that to solve this, it's pretty straightforward because all you need to do is just a simple chain rule getting involved, right? So let's handle that. That is infinity. You're gonna have e to the power of negative x to the power 8 over let's see, it's gonna be negative 8, right? Because if you take the derivative of this, it's going to be the derivative of this one, and then times the derivative of this part. That's going to give you negative 8x to the power 7. Well, we only have x to the power 7 here, so we need to divide in negative 8. And then from negative b to b. Okay. Let's see, how do we handle this? In fact, we don't even to check about this part, right? Because if you plug a b or negative b here, do you realize that you're going to always have b to the power of 8? There, of course, there is negative. So in other words, if you plug in to this, so it's e to the power negative b to the power 8 over negative 8 minus e to the power negative, since negative b to the power 8 is still it's going to be b to the power 8 over negative 8. So to realize that those two are identical, so it's going to give us it's a 0. Okay, so go back to the problem here. Let's see, do we have the answer 0 for this improper integral? The answer is yes. Okay. So that's the first two. Number 3, we can look at number 3 here. It said that evaluate the integral, right? This improper integral from negative 8 to 1 dx over x to the power of 2 over 3. So this is a thing. This is a type 2 improper integral, and why we call this type 2 improper integral? Because you see that from negative 8 to 1, you need to pass the value 0, right? And the function or the integrand for this integral here, it's 1 over x to the power of 2/3. In other words, is not defined at x equals 0. Okay, but I mean, what we can do? Well, in fact, for this problem, it's also not that difficult to verify, because what we can do is evaluate this is simple, right? And then you can just plug in what you have, and then that should be good enough to handle this problem. Okay, to handle this problem here. So let's see, let me use a new paper to work on with that. So see, so it's negative 8 to 1. Actually, you can do it into this, right? Into this one. If you do the evaluation here, this number 3, right? So it's x to the power 2/3 plus 1 over negative 2/3 plus 1. You can just do this evaluation. It's not an issue. So you're going to have the negative cube over negative 1/3 over 1/3, 1 to negative 8, and there's a 3 x to the power 3rd from negative 8 to 1. So you just plug in 1 minus 3 times negative 8, 1 cube. So this part is it will give you negative 2 times negative 3. It's going to become into 6. So this part is 3. So to 3 plus 6 to us is 9. Okay, so that's the answer is C. Okay, that's number 3. Number 4. So determine whether this improper integral converges or diverges. By meaning converges or diverges, that means that okay, if this improper integral gonna have a value or not, okay, or a fixed value or not. So number 4, you see from 2 to infinity, 3x plus 1 squared dx. We can still try to evaluate into this way. Okay, and then you can see we can do the integration for this one is also simple because you're going to have it's negative 3 over x plus 1, right? So that's the integration, I believe. Right? Because if you take the derivative of this, eventually we'll go back to here. And then evaluate it from 2 to b. So if we plug 2 inside of here, that's going to give us, it's 2 plus 1 to 3, so it's a negative 1 minus negative 3 over b plus 1, right? And then when b goes to infinity, do you see that this part will become a 0? So this improper integral actually it converges to negative 1. Okay, so this converges. Okay, so that's about the first full problem for the improper integral part. Okay, so hope you enjoy this.